Hi, super scientists. We're going to be looking at 5.1 Exploring the Ocean, and we'll be looking at the movement of the ocean floor. So there's several different movements that take place on the ocean floor, some of which you probably talked about several years ago, maybe in 6th grade. So one thing is seafloor spreading. So literally seafloor spreading is just the spreading of the sea floor. And sea referring to ocean. Sea and ocean are used interchangeably. So when you hear seafloor spreading, you need to think the ocean floor spreading. So it's literally just the process of new ocean floor being created. So when plates move apart, as you can see this animation, this plate is moving this direction, this plate is moving this direction. That allows for a crack or a little fissure in the ocean floor, which will allow magma, literally hot melted rock, like what you have erupting from a volcano, to come up to the ocean surface. So when that magma moves upward and comes in contact with the really cold ocean floor, which most times is just a couple degrees above freezing temperature, so maybe 2 or 3 degrees Celsius. So when it comes in contact with that really cold water, it will harden and turn into new rock, which becomes new ocean floor. So you probably talked about in 6th grade the theory of plate tectonics. So plate tectonics just basically says that Earth's crust, which is the outer layer of our surface, is broken into plates. And those plates, those tectonic plates, move around. So they move not all the time, but they periodically will move. And all the tectonic plates move at the rate of about a couple inches a year. So in locations where you have a lot of tectonic activity, like in California, you may be able to see results of that. Whereas in our area, we aren't necessarily at a plate boundary, the closest plate boundary being here and down here. So we're not really going to see the effects of that immediately. So one type of boundary that you might see at tectonic plate activity areas is going to be divergent plates. So your stem di refers to the same thing as bi, bi, which means two. So the plates are going to be moving in two different directions. Your stem verge refers to turn or slant. So literally those two plates are going to be moving in different directions. And you can see that in this little animation, the plates are pulling apart and you have convection that's taking place, literally convection currents in the hot melted magma and this hot melted rock from inside the earth. So that material gets really heated up, and when it becomes heated up, it becomes less dense, so it's going to move up to the surface, and then it will become sort of cooled down by contact with the cooler area you have at the bottom of the ocean. So then its density increases, so it sinks, and then it's heated up again. So that's how you have that movement in the magma that's taking place with the convection currents. Another type of plate boundary is convergent. So your stem con means together, so plates will pull together, they will move together at convergent plate boundaries. And you can have several different types of features that are formed at convergent plate boundaries. So one thing is underwater mountains called seamounts. So you can have lots of different mountains that are formed. You can even have underwater volcanoes that will be formed, and that's what you see in this picture here. So this is a bathymetric map. Bathymetry refers to basically graphing and looking at the lay of the ocean floor, so looking at the topography of the ocean floor. So at this volcanic area here, you will have lava that can come up to the surface because of pressure. And this is a picture showing you volcanic activity from Mount Kilauea in Hawaii. So at convergent plate boundaries, plates are going to move together, as you see in this animation, and you can have volcanic activity, you can have mountains form, and if the plates are of different densities, like an oceanic plate and a continental plate, the continental plates are going to be less dense than the oceanic plate. So the oceanic plate will subduct, it will move downward under a continental plate if there's a convergent plate boundary, which can also cause trenches to form. So like you may have heard of the Marianas Trench, that's an example. So this is a trench, it's just sort of a depression in the ocean floor. The next plate boundary is a transform boundary. So trans means across. So at transform plate boundaries, plates are going to be moving across. They're moving past one another. So you can see that very slow action that's taking place here at the transform plate boundary in this animation. So you have little earthquakes that take place, and that's going to cause a shift in the plate. So literally they just move past. They're sliding past one another. So they're not moving towards one another. They're not pulling apart. They're just sliding horizontally. And the most well-known transform plate boundary is going to be the San Andreas Fault, which is right here. So this is in California. And if you've seen the movie San Andreas with The Rock, then that is where that movie is set, is in California at the San Andreas Fault. So that's a transform plate boundary. So this section of California, where Los Angeles is located, is actually moving north. It's moving up the California coast, moving really slow, like an inch or two a year, but eventually this section will be further up north than it is currently. Where you have two plates diverging, magma is going to be able to come up to the surface of the ocean floor. So up to the bottom of the ocean, where that magma will come in contact with ocean water, and that is where you're going to have this seafloor spreading at the mid-ocean ridge. And you can see the plates that are pulling apart here, magma's coming up to the surface, and this whole area is referred to as the mid-ocean ridge. So seafloor spreading is a process that takes place at the mid-ocean ridge. Where you have converging plates, you'll end up having a trench, which you were just looking at a second ago. So here's your converging plates. The one plate here is subducting, so you have subduction happening right here, and this continental plate is less dense, so it's going to be the one that stays closer to the top, whereas the oceanic plate is going to be more dense, so it sinks, and then it eventually will get heated up so much that it will melt and turn into magma, which can then be erupted through the volcano that you have here. Your stem sub means under, so that's a good way you can remember subduction. So this is a map showing you the bathymetry or the topography of the ocean floor. This is also in your textbook if you can't see this for some reason, but these are some different features of the ocean floor that you're going to need to know. So you can look at the graphic that you have in your notes and be able to fill in the names of the different points. So the abyssal plain is right here. If you've talked about plains in social studies, like the coastal plain, for example, a plain is going to be a really flat area. So that's what the abyssal plain is. Volcanic island is basically a seamount. So the seamounts here, underwater mountains. So volcanic island is going to be a seamount that's tall enough to where it will protrude through the surface of the ocean and you'll be able to see it. That's how Hawaii was formed, volcanic island. So it's from cooled magma. The islands like Hawaii are not just floating on the water. They are actually attached to the bottom of the ocean with rock that extends all the way up to the surface. So really tall. Mid-ocean ridge is going to be where seafloor spreading occurs, seafloor spreading. So it is going to be an area where the plates are pulling apart, they're diverging, and magma is allowed to come up to the surface, and it cools down, forming new ocean floor. So the newest ocean floor is going to be in the center. The oldest ocean floor at the mid-ocean ridge is going to be the mountains that are further away. The continental shelf and continental slope are a couple of features that are at coastlines. So if you go to the beach and go in the water, actually swimming in the water at the ocean, then you've been walking on the continental shelf. So it's that area where it gets a little bit lower, a little bit lower, a little bit lower, a little bit lower. Eventually you're up to your knees in water, then up to your waist in water, and then you can't touch the bottom anymore. That's because you're walking downward on the continental shelf. And then the continental slope, I like to think of it as a ski slope if you've ever been skiing before. So the ski slope just dips downward just like the continental slope does here. It's a really quick drop off. And the continental shelf and continental slope are different from the Atlantic Ocean to the Pacific Ocean. So if you've ever been to the Pacific Ocean, like in California, then it has a really short continental shelf, and then it immediately drops off. So it doesn't have this area where it gets lower and lower and lower. It gets lower and then drops off. So the continental shelf is much shorter in the Pacific Ocean side. And then trenches, we were looking at those earlier. So a trench is just going to be a really low valley kind of area on the ocean floor. So mid-Atlantic ridge, you're going to have underwater mountains, and that's where sea floor spreading occurs.